All right, your Federal Highway Association Bridge Inspector Manual, Section 3, Fundamental Bridge Inspection. Section 3, Fundamentals Bridge Inspection. Duty of Bridge Inspection Team. Introduction. Duties of Bridge Inspection Team. Planning and Inspection. Preparing for inspection. Review bridge structural file, bridge plans, previous inspection reports, maintenance repair records, rehabilitation plans, geotechnical data, hydrologic data, roadway plans, additional data. Identify components, elements, deck, element number, section, system, structure, element numbering system, substructure, element numbering system, development, inspection, sequence, pair organization, note, traffic control, special consideration, time requirements, peak travel time, setup time, access, weather, safety precautions, permits, tools, subcontracting, special activities, performing the inspection, general inspection procedures, approaches, decks, substructures, bearings, substructure, waterways inspection, bridge element, timber inspection, concrete masonry inspection, steel and iron inspection, preparing for the report, identifying items, repair and maintenance, follow up with the critical findings, typical types of bridge inspection, initial inventory, routine, periodic damage, in depth, special interim. Alright, fundamentals of bridge inspection, section 3, topic 3.1, duties of bridge inspection, 3.11. Bridge inspections playing an increasingly important role providing safety infrastructure for the nation. The nation's bridges continue to age and deteriorate inappropriate throughout the assessment. Each bridge condition is critical in maintaining a dependable highway system. There are 5 basic types of inspection: initial inventory, routine, periodic, depth, in-depth, special, interim. They are discussed in Article 3.2 of the AASHTO Manual for Condition Evaluation of Bridges. Although the topic is organized in depth inspection, it applies to all inspection types. However, the amount of time and effort required to perform each duty will vary with the type of the inspection performed. Sections presenting with the duties of the bridge inspection team. It also describes how the inspection team can prepare the inspection, some of the major inspection procedures. For some duties, the inspection program manager may be involved. 3.12 Duties of Bridge Inspection Team. The 5 basic duties of the bridge inspection team: planning the inspection, preparing the inspection, performing the inspection, preparing the report, identifying items of repair and maintenance. The duties of the inspector are simply tasks that must be performed in order to fulfill the responsibility that come with that job. Planning the inspection. In order to make the inspection orderly and systematic, the lead inspector should make plans in advance. Planning the inspection is necessary for an efficient and cost-effective effort that will result through in complete inspection. Basic activities determine on the type of the inspection, selecting the inspection team, which may include qualified team leader on site, initial routine, depth, in-depth fracture critical member underwater inspection evaluation required activities, non-destructive testing, underwater inspection, development inspection sequence, establish the schedule, preparing the inspection. Preparation measures needed for the inspection include organization, proper tools and equipment, and the review of the bridge structure file, locating file plans of the structure. Success on the field side, on-site field inspection largely dependent on the effort spent in preparing for the inspection. Major preparation activities include: review the bridge structure file, identify the components and elements, develop the inspection sequence, prepare organization notes and forms and sketches, arrange of the traffic control, make arrangements for required methods of access, review safety precautions, organize tool and equipment, arrange subcontractor special activities, accounting for other special consideration. Review bridge structure file. The first step of preparing bridge inspection is to review mainly available sources of information about the bridge, such as design and as-built bridge plans, previous inspection report, maintenance, repair records, rehabilitation, retrofit plans, geotechnical data, hydrological data, roadway plans, utility plans, right-of-way plans. Bridge plan. The bridge plan contains information about the bridge type of the number of the spans used, simple and continuous spans, material of construction. They also contain information about presence of composite actions between decks and girders, using frame action of the substructure member, and kind of the connection details used. The year of the construction, design, loading are usually contained in the bridge plans. Inspector reviewing the bridge plans. Previous inspector reports. Previous inspector reports provide valuable information on the history of the bridge. Documentation is contained in previous years. The information can be used to determine whether the components and elements of the bridge warrant special attention. Allow the inspector to compare the current level of deterioration with those noted during previous inspection to help determine the rate of deterioration. Maintenance and repair records. Maintenance and repair records allow the inspector to report all subsequent repairs during the inspection phase, noting type, extent, and dates on the repairs. Rehabilitation plans. show modification or replacement performed on the structure just as in the design plans as built or record drawings are preferable. Geotechnical data. Geotechnical data provides information with the foundation material below the structure, sand, silt, clay, with more suspectable settlements, cure problems than is rock. Therefore, structure found on these materials should be generally be given more attention and respect to the foundation's core issue than those found on the rock. Hydrological data. Hydrological data provides information about the shape and the location of the channel, the presence of the protection devices, flood frequencies, water elevation for various flood intervals. Information is needed for the score elevation expected for the fluid flow, water velocity. Roadway plans may provide some information when the structure plans are not available. Additional data. Utility plan can be used to determine the types and the number of the utility attachment right-of-way. Plans can be used to determine the limits of the right-of-way, which could be a factor determining access requirement. Identifying code and elements. Another important activity preparing the inspection is to establish structural orientation as well as identify the various components, elements of the bridge. Figure 312. If the drawings and previous inspection reports are available, notification system using the during this section be same as used in these sources. Span 1, span 2, span 3, span 4, span 5, abutment 1, abutment 2, bent or pier 1, pier 2, pier 3, bent or pier 4. In previous records, available inspectors should be established identification system. The numbering system presented with the subtopic 1 is possible system, but sometimes may be used different numbering system. Route of the direction can be determined based on the mile marker stationing. Direction should be used to identify the beginning and the end of the bridge. Deck element numbering system should be included with the deck section between the construction joints, the expansion joints, the railing, the parapets, the light standards. These elements should be numbered consecutively beginning and the end of the bridge. Alright, your superstructure elevating number system. The superstructure elevating number system should include the span of the beams and cape of the trusses of the panel plate and plate points. The span should be numbered consecutively with the span one located beginning of the bridge. Multiple beams should be numbered consecutively left to the right of the facing of the route direction. Similarly, with the spans, floor beams should be numbered consecutively from the beginning of the bridge, but the first floor beam should be labeled as floor beam 0. This will coordinate with floor beam with the bay numbers so that they are given floor beam number. It will be located at the end of the corresponding bay. For trusses and panel number, there should be the number assignment similar with the floor beams beginning with a panel 0, label both upstream and downstream truss with the points of some vertical line with the same number. There is no lower panel point with a particular line, vertical line. The numbers of lower chord will skip the number of figure 313. Some of the design numbers are midspan of the trusses. Numbers backwards to 0 using prime numbers. However, the numbering of the system is not recommended for the field inspection use since prime designation infield notes may be obscured by dirt. Alright, samples numbering trusses U through 10, M 1, 3, 5, 7, 9, and L is 1, 2, 4, 6, 8, 9, and 10. Substructure element numbering system. Substructure element numbering system should be included in abutments and piers. The abutment located with the beginning of the bridge. Abutment 2 is located at the end. Piers should be numbered consecutively with pier 1 located closest to the beginning of the bridge. Alternately, all substructures may be numbered consecutively without noting abutments or piers. Development inspection sequence. Inspection normally begins with the deck with the substructure elements preceding the substructure. However, there are many factors that must be considered with the planning of the subsequent inspection of the bridge, include type of the bridge, the condition of the bridge components, the overall condition, inspection agency requirements, size and complexity of the bridge, traffic conditions, special procedures, sample inspection, sequence, bridge average length, the complexity presented in 3.1, table 3.1.1. Developing inspection sequence is important of the value following ensuring the complete through an inspection bridge. 1 is roadway elements, approach roadway, traffic safety features, general alignment, approachment, alignment, deflection, settlement. 2, bridge, deflex, expansion, joint, sidewalk, railings, drainage, siding, signing, electrical lighting, barrier gates, other traffic control devices, bridge deck, soffit, superstructure elements, bearings, main support bearing members, secondary members, embracing utilities, anchorage. 4, substructure elements, abutments, skew packs, arches, slope, protection, pier, footings, piles, curtain walls. 5, channel waterway elements, channel profile, alignment, channel stemming bed, channel embankment protection, fenders, dolphins, hydraulic opens, water depth scales, navigation lengths, and aids. Preparing notes and forms of sketches prior to the on-site inspection elements unnecessary to work on a field copy for the agency standard form inspection should be obtained with the use of the record-keeping checklist to ensure condition of the elements is noted. Photocopy sketches for the previous inspection reports of the device for the previously documented can be simply be updated. Preparing extra copies to provide a contingency for sheets that may be lost and damaged in the field. And previous sketches not available to pre-made, the generic sketches may be used for the repetitive function members but possible application for the time saving of the procedure, including deck section, floor systems, bracing members, abutments, piers, and retaining walls numbered with a pre-made sketch for the forms also can provide a quality control on work completed. Our bridge inspection like construction maintenance activities on the bridge, often the pre-site mortars, unexpected, unusual situation. Most state agencies adopt the manual of uniform traffic control of the device of the street and highway or MUT CD. Some states of local jurisdiction have the issue with their own manuals working and exposed with the traffic. The bridge inspector should check follow the governing standards. These standards prescribe the minimum procedure for the number of typical application proper use standard traffic control device such as cones and signs and flashing arrow boards. Principal procedures when enhancing safety motorist bridge inspectors in working areas include traffic safety should be a high priority element on every bridge inspection project for the inspectors. Activities are exposed to high traffic likely to affect normal traffic movements. Traffic should be routed throughout the work area with a geometric traffic control device comparable to those employed on other highway situations. Traffic movement should be inhibited as little as practical. Approaching motorists should be guided with a clear and positive manner throughout the bridge inspection site. On long durations inspections, routine inspection of traffic control device should be performed. All personnel responsible for the performance of traffic control operations should be adequately trained. In addition, schedules may have been adjusted to accommodate traffic control needs. For example, the number of the lanes could be closed at one time, maybe to require conducting inspection operation with less optimum efficiency. While it might be most efficient to inspect floor system left to right, the traffic control may dictate the working full length of full few beams at a time. Special consideration time requirements. The inspection report with the bridge record with the file should state a moment of time required with the inspection. Inspection time requirements should be broken down into office preparation, travel time, field time, report preparation. Overall condition of the bridge will play a major role in determining how long the inspection will take. The previous inspection reports provide indication of the bridge's overall condition. Journal takes more time than inspection of the document. Deteriorated element, measuring, sketching, photographing than it does to simply observe the document of the element in good condition. Peak travel times. In populated areas, inspection requiring traffic restrictions may be limited to certain hours of the day, 10 a.m. to 2 p.m. Some days may be banned from inspection work altogether. Actual inspection time must be less than 40 hours a week in these situations. Its schedule should be adjusted accordingly. Setup time must be considered both before and during inspection. For example, the rigging efforts may require several days before inspectors arrive on site. Also, other equipment such as compressor cleaning equipment may be required daily setup time. Adequate time should be provided with a schedule for setup and takedown time. Requirements of the time install remove traffic control devices must also be considered. Alright, access. Access requires most of the considerable preparing for an inspection. Bridge members may be very similar to each other. They may require a different amount of the time to gain access to them. For example, it may take longer to maneuver a lift device to gain access to a floor system near utility lines than for one that is free of obstruction. On some structures, access hatches may need to be opened to gain access to the portion of the bridge. Weather. Adverse weather conditions may not halt the inspection entirely, but they may play a significant role in the inspection process. During adverse weather conditions, climbing should be generally avoided. There should be an increased awareness of safety hazards. Keeping notes can be difficult. During seasons with poor weather, less aggressively schedules should be adopted during the good weather months. Safety precautions. When completing inspection timely, efficient manner with important safety precautions cannot be overlooked. The inspection team member must follow the general guidelines of the safety inspection confined space inventory. Procedures must be in accordance with OSHA. The only requirement of climbing with inspection. 3 basic requirements. Safe climbing must be followed. For additional information, safety precaution, refer to topic 325. Permits. Inspection bridge owned by the crossing railroad and access permits generally must be obtained with receiving the field inspection permit. Must also be obtained with inspecting bridges, passing over navigable waterways. Environmental permits and permits to work around endangered species may be required for some bridges and bridge sites. Alright, tools. To perform a complete, accurate inspection, the proper tools and equipment must be used. Bridge location are two main factors in determining required tools and equipment. Refer to topic 3.4 with a complete list of inspection tools and equipment. Subcontractor special activities consideration must be given in the time requirements. Special activities must be scheduled. These activities may include one or more of the following: maintenance, protection of traffic, access, including rigging inspection vehicles and combination thereof, the coordination of various railroads, including obtaining service of the railroad flagman. 315 performing inspection. Duties on-site work and assessing and examining the bridge components, waterway if present. Examination procedures are noted with the NBIS. Should be always followed. Basic activities include visual examination, bridge components, physical examination, bridge components, evaluation of bridge components, examination, evaluation, waterway beneath the structure, if any, approach roadway geometry. General inspection procedures. Duties associated with inspection, maintaining with the proper structure and orientation. Remember the numbering system following with the proper inspection procedure. Procedures used to inspect the bridge depending largely on the bridge type of the materials used with the general good condition of the bridge. Therefore, the inspector must be familiar with the basic inspection procedure, wide variety of bridges. The first step of the inspection procedure to establish orientation of the site of the bridge. The orientation should include the compass direction, the direction of water flow, the direction of inventory route. Also, record inspection team, air, temperature, weather, condition, and time. After the site orientation has been established, the inspector should be ready to begin with the on-site inspection. The inspector must be carefully attentive to the work hand on no portion of the bridge should be overlooked. Those portions are more critical to the structural integrity of the bridge should have been given them the attention. For topic 8.1 with the description fracture critical members in steel bridges. Prudency during inspection must be combined with through complete record keeping. Observation should be careful and attentive. Every defect should be recorded. Every very careful inspection worthy, no more than records kept during the inspection. Number and letters should be crayon and painted on the bridge to identify the code components, the elements of the structure. Purpose of the marks is to keep the inspector location to guard against overlooking any portion of the structure. Inspector should note the general approach of the roadway alignment and sight along the railing and edge of the deck with the grader to detect misalignment and settlement. Approachment of slabs and decks. Inspector should check the approach of the pavement, unevenness, settlement, roughness. Also check the addition of shoulders, slopes, and drainage. Approach guardrail. Deck and sidewall walks should be examined with various defects and noting size, type, and extent, location of each defect. Location should be referenced. Either the center line, a curb line, span, number, the distance of specific pier or joint. Examine the expansion joint for the sufficient clearance of adequate steel. Require width of joining opening on both curb lines, noting the air temperature, general weather condition at the time of the inspection. Finally, check the safety features of signs, lighting at present, note their condition. Alright, your superstructures must be inspected thoroughly with since the failure of the main supporting member could result in the collapse of the bridge. Most common forms of the main supporting members are beams and girders, floor beams and stringers, trusses, catenary suspender cables, eye-bar chains, arc ribs, frames, pin and hanger plates, bearings. The bearings must also be inspected thoroughly since they have provided a critical link between substructure and superstructure. Record the difference between rocker, tilt, and fixed reference line, noting the direction of the tilt, the air, bearing material, temperature, and the general weather condition at the time of the inspection. Substructures. The substructure which support for the substructure is made of the abutments, piers, and bents as built plans. Available the dimension substructure should also be compared with the presented on the plan, since the primary method of the bridge inspection is visual. All dirt, leaves, animal waste, debris should be removed. All close observation evaluation substructure units should be checked for settlement site along with a substructure, noting all tilting vertical faces of the conjunction with the score inspection waterway substructure units should be checked for undermining, noting both external and external location. Alright, waterways are a dynamic nature. They volume of flow in their path. The continual change of the bridge passing over them must be carefully inspected for the effects of the changes. Records shall be maintained with the channel profile alignment, noting any of the meaning of the mendering of channel both upstream and downstream. Report any skew and proper location of the piers and abutments relative to the stream flow. Score the erosion of riverbed or area caused by stream flow. The primary concern is evaluating the effects of the waterways on the bridge. See figure 315. The existence and extent of the score must be determined by the grid using a grid system, noting the depth of the channel bottom at each grid point. Alright, 315 shows inspection score undermining. Embankment erosion should be noted with both upstream and downstream of the bridge. If the debris is excessive vegetation, record the type and size of the extent and location of all high watermark referencing fixed elevation, such as bottom and substructure, bottom of superstructure. or an inspection of bridge elements. Inspectors must be familiar with several general terms of the described in bridge defects. Corrosion, rusting, cracking, breaking away with the separating into two parts, splitting, separating into parts, connecting slippage, relative movement of the connected parts, overstress, the deformation due to overload, collision damage due when the bridge is struck by vehicles or other vessels. Refer to Section 2 for the more detailed description types of the cause of the deterioration of specific materials. Described in Section 2, each material is subject to unique defects, therefore, inspectors should be familiar with the different inspection time or procedures used when each material. Timber inspection. When inspecting timber structures, determine the extent and severity of the decay, weathering, wear, being specifically about the dimensions, depths, and location, sound, probe, timber, defect, hidden deterioration due to decay, inspection, marine bores. Note any large cracks, seals, splits, crush area when collision overload with the damage may cause the difficulty. The inspection should be factual, avoiding speculation. The cause, note any fire damage, record of the measurement. Remaining sound material, document any exposed untreated portions of the wood, indicating type and size, location. Alright, concrete and masonry inspection. Inspection concrete structures, note all visible cracks and record their type, the weight, width, length, and location. Rust and the effluent stains should also be recorded. Concrete sculling can occur with exposed voices. The concrete surface and its location and depth of the general characteristics should be recorded. Inspect concrete surface deterioration, delamination, hollow zones, which are areas incipient spalling. Use the hammer of chain drag. The delamination should be carefully documented using sketch showing the location and permanent dimensions. Unlike delamination, spalling is readily visible. Spalling should also be documented with a sketch and photos noting the depth of the spalling, presence of the exposed reference steel, the deterioration and section loss that may be present with exposed bars. Examination of stone, masonry, mortar is similar with that of concrete. The joints should be carefully inspected for the cracks. Other forms of mortar deterioration inspection techniques are generally the same as for concrete. Masonry archways, masonry founded concrete archways should be checked for mortar cracks, vegetation, water, seepage through the cracks, loose and missing stones, blocks, weathering, spall, or split block stones. Alright, steel and iron inspection. When inspecting steel and iron structures, determine the extent and severity of the corrosion. Carefully measure the amount of cross section remaining. All cracks should be noted, recorded length, their length, size, and location. Bend and damaged members should be documented, noting the type of the damage, amount of the deflection. Loose rivets and bolts can be detected by striking them with a hammer while holding the thumb on the opposite end of the rivet. The movement will be felt when loose. If, in addition, with any missing rivets, the bolts should be noted. Note any freezing pins, hangers, expansion device on. One indication of this is hanger expansion rockers are inclined, rotated the direction opposite to the expanded from the current temperature. Cold weather rocker bearings should be leaning towards the fixed end of the bridge, and in hot weather it should lean away from the fixed end. Lock bearing is generally caused by the heavy rust on the bearing elements. For inspector evaluation substantiated, all inspection findings must be documented, recorded. Documentation referred as condition remarks on inspection form and inspection report. 316. Preparing the report. Document is essential for any type of inspection. Inspector must gather enough information to ensure the comprehensive, complete report. Report preparation is a duty with a reflex effect of the inspector puts in performing inspection, but must be compressed of the report of the record, both in bridge condition. Inspector works basic activity preparing inspection report included completion, agency forms, objective written documentation, all inspection findings, photo for references, and sketches of objective evaluation of bridge components, recommendation, cost estimates, summary, a simple sample bridge inspection report found in Appendix B of this manual. Alright, 317, identifying items, repair, and maintenance follow-up, critical findings. Finally, the final basic duty is to identify the items, repairs, and maintenance. Inspector must identify such items, promote remote public safety that maximize the longevity of the bridge. Most recommendations concerning the repair of the category-prone repairs, i.e. repairs that are incorporated into program repair and maintenance schedules. Example of the maintenance activities include flushing the deck, flushing the scuppers, downspouts, lubricating the bearings, and painting the structure. Inspector must be carefully consider the benefit derived of the making of the repairs consequence, and such repairs are not made. All inspectors should be checked with the previous report recommendations, see whether repairs and or maintenance identified with the protect. Prior to such item, the repairs were to be completed before the next inspection. It is the responsibility of the inspector to note that the repairs have been completed after appears satisfactory. Alright, the updated NBIS regulation required procedure follow-up with the critical findings A statewide federal agency procedure must be established to ensure the critical findings addressed with a timely manner. The Federal Highway Administration must be periodically notified of actions taken as a result of the minor critical findings. Critical findings define structural safety related deficiencies that require immediate follow-up inspection or action. It is responsible of the bridge owners to implement procedure for addressing critical deficiencies include immediate critical deficiency report steps, emergency notification of police and public, rapid evaluation of the deficiency, rapid implementation of the correct and protective action tracking system to ensure adequate follow-up, provisions identifying other bridges with similar structural details for follow-up inspections. Alright, types of bridge inspection. Type of inspection may vary over the useful life of the bridge to reflect with the intensity of the inspection required with the time of inspection. Into the 5 types of inspection listed below of the bridge owner establish appropriate inspection level consistent inspection frequency with the type of the structure and details. Initial inventory. Initial inspection. First inspection bridge becomes a part of the bridge file with the elements of the initial inspection may also apply when there has been a change of the configuration of a structure, widening, lengthening, supplemental bends, changing in the bridge ownership. The initial inspection fully documented investigation accompanied with a load capacity rating. First inspection provide with a structural inventory appraisal and data. Secondary provides a baseline structural conditions identification of existing problems. Alright, your routine periodic. Routine inspection regularly scheduled inspection consisting of observation measurement as needed to determine the physical and functional condition of the bridge, identify any change with the initial previously recorded conditions, ensure the structural continues and safety present, serves condition inspection underwater portion of the substructure limited to observation during low flow periods and probing from the signs of the undermining of the area of the structure of the closely monitored of those during determined previous inspection load rating calculation to be critical and load carrying capacity. According to the NBIS, each bridge must be inspected with regular intervals not exceeding 24 months. However, certain bridges require inspection at least each biannual cycle. Criteria must be established to determine inspection frequency and intensity based on such factors: age, characteristic, non-deficiency. Certain bridges may also be inspected with a greater than the 24-month interval not exceeding 48 months with prior Federal Highway Administration approval. The major appropriate with the basic inspection findings analysis justify increasing inspection intervals. Underwater structural elements are to be inspected at regular intervals not to exceed 60 months. However, certain underwater structural elements require inspection less than 60-month cycle. Criteria must be established to determine the inspection frequency and intensity based on the such factor, construction, material, environmental aid score, characteristic condition rating from the past inspection, known deficiency. Certain underwater structural elements may be inspected with greater than 60-month interval, not exceed 72 months within prior Federal Highway Administration approval. This may be appropriate when past inspection finds analysis justified increased inspection and frequency. Fracture critical members are to be inspected regular intervals not less than 24 months. However, the certain fracture critical members require inspection at least less than 24-month cycle. Critical criteria must be established to determine inspection frequency and intensity based on such factors as age, traffic characteristics, and known deficiency. Alright, your damage. A damage inspection, unscheduled inspection acts if the structural damage result of the environmental factors of the human action or the scope of the inspection should be sufficient to determine the need for emergency load restriction or closure of bridge traffic success level effort necessary to effect repair timely depth inspection may eliminate the need for the inspection. Alright, your in-depth. In-depth inspection, close-up of the inspection, one or more of the members above or below the water level identified with any deficiency not readily detectable using the routine inspection procedures. Hands-on inspection may be necessary at some locations. When appropriate and necessary, fully ascertain existence or the extent of any deficiency. Non-destructive field tests may be denoted with the be performed. Inspection may be to include load rating and assess the residual capacity of members, and depending on the extent of the deterioration of the damage. For a small bridge in depth, inspection should include all critical members of the structure. For a large complex structure, these inspections may be scheduled separately with the defined segments of the bridge and designated groups of the elements connection to the details. According to the NBIS, criteria must be established to determine the level, the frequency, of the type of the inspection. Special interim. A special inspection and inspection scheduled with the discretion of the bridge owner is on the monitoring particular known with the suspected deficiencies such as foundation, settlement, score, fatigue, damage, public use of the load, posted, damaged bridge. Guideline procedures to be observed and measured must be provided timely process with interpretive field results should be in place if the inspections are not usually comprehensive enough to meet the NBIS requirement period inspection. According to NBIS, criteria must be established to determine the level of frequency type of the inspection. Alright, type section 3, fundamentals of bridge inspection. And then we're going to cut the tape there. Testing.